Hello, all my dear students. I welcome you all to Chakravyuh Academy. I hope that all of you are doing well. Since CBSE has released the board exam date sheet for 2024-25, so I have planned to start a series in which chapter wise I will explain you all the important graphs, and obviously we'll discuss the reason also that why the shape of that graph is maybe a straight line, maybe a decreasing graph, maybe a combination of both. And sometimes they ask numericals also. They ask you a numerical by giving some data. You solve that numerical, you get that expression, and after the expression, they ask you to draw the graph. So I have just collected a few previous year questions where they have asked us to draw the graph, maybe in the form of MCQs or maybe in the form of subjective. So let's start the session. So if you see that the first topic is electric field due to an infinitely long straight conductor. So what is the electric field due to this type of conductor? The formula is lambda divided by 2 pi epsilon naught r. What is lambda here? Lambda is called linear charge density, which means charge per unit length. If you observe one thing here, just observe the expression that electric field and distance are inversely proportional. So if they ask us to draw the graph between electric field and distance from the conductor, what will be the shape? I think the graph is already drawn here, but let me draw it again. So since it is inversely proportional, okay. So whenever two parameters are inversely proportional, the graph will be a decreasing graph. See carefully. अगर इसको ध्यान से देखो, you can clearly see that it is basically a decreasing graph. When distance is increasing, electric field is decreasing. So funda is very simple. When the two parameters are inversely proportional, you will draw the graph like this. And I already explained what is lambda, charge per unit length. It is called linear charge density. Okay. And if you see the diagram also, I will just quickly explain the direction of electric field. It is positively charged conductor. Electric field is always outward. You can take a negatively charged conductor also. Then what will happen? The electric field will be inward. Okay. So if they ask you the direction, this is a magnitude. You are supposed to remember this formula. Direction is normally outward. Okay. Now let's take the next graph. So the next topic what we have is electric field due to a infinitely big charged sheet, and how it is charged uniformly, means charge distribution is uniform. So you can see that this is a very big sheet which is uniformly charged. We have taken positive charge, means field lines will go outward. You can see that outward, outward. So what is the formula for the electric field due to this uniformly charged sheet? It is sigma by 2 epsilon naught. What is sigma here? Sigma is basically surface charge density, charge per unit area. If you notice one thing here, is the electric field depending on the distance? Answer is no. It is independent of the distance. So if I am present at a distance of 1 centimeter or 1 meter from here, and if I take one more point which is at a distance, suppose 4 meters, 5 meters. So at both the distance, electric field the magnitude is going to be same. If they ask us draw the graph, since you know that electric field is independent of the distance. So if it is independent means if I change the distance, electric field will remain constant. So electric field will be constant means a flat line. And what will be this value? Sigma by 2 epsilon naught. They are independent of each other. So graph will be like this. Okay. I hope that funda is clear rather than just mugging up. You need to understand कि उसके पीछे reason क्या है. That is important. Okay, it is independent of the distance. So let's discuss the next topic, which is the electric field due to a uniformly charged shell. Shell means hollow sphere. So electric field due to a uniformly charged thin spherical shell. The shell means a hollow sphere. There's nothing inside, hollow. So let's discuss this quickly. So let's draw a shell here. I'm repeating again, what is the meaning of shell? Shell means a hollow sphere. Hollow sphere means there is no charge inside. So whatever charge is present, charge should be present on the surface. Understand that. Whatever charge will be present, the charge will be present on the surface. Suppose the charge present on the surface is Q. radius is capital R. In this, you have to take 3 points. One point which is inside the shell, second point which is on the shell, and third point which is outside the shell, shell ke bahar. So 3 points you have to consider. So the electric field at any point inside the shell, क्या value होती है बच्चों? Which is 0. Okay. Now, if you take, this is basically I will write electric field inside. If I take a point, suppose P here, which is outside and at a distance of R. Okay. I'm taking a point P. I'm asking boss, tell me what is the electric field at an exterior point, which is point P, due to this uniformly charged shell. तो क्या फॉर्मूला होगा इसका? Just remember one statement what I'm telling. For any point which is outside the shell, what you have to do, you just forget the shell. Just ignore the shell. You just assume that whatever charge is present on the shell is present at its center. You just ignore the shell. So take this charge, keep it at the center. So due to the charge present at the center, what is the electric field at point P? What is the formula due to a point charge? Electric field due to a point charge, KQ by R squared. So you forget the shell, take the charge on the shell at the center. So this Q is here now, KQ by R squared. KQ by what is the distance? Small r. If I ask, third point, that what will be the electric field on the surface or on the shell, then what will you do? If the point P is on the shell, so what is the distance? Small r will be equal to capital R. So this will become what? K capital Q divided by capital R square. Okay. You should know the derivation also. They ask derivation also. Here I am explaining all the graphs and the expressions, but derivation is also important. So if I draw the graph, see the graph, students. For a point inside, okay, suppose if I mark this, okay, so suppose this is capital R, capital R. So what is the electric field at any point from the center till the circumference? 0. So from here till here, electric field is 0. The moment I go to the surface, the electric field is this, KQ by capital R square. Capital R is a constant value. So this is the electric field. What is the electric field? K capital Q by R square. If you see, the moment we move outside, the electric field is inversely proportional to R square. The moment it is inversely proportional, we discussed that it will be a decreasing graph. Okay, so from here to here 0, at surface KQ by capital R square. After that, it will be decreasing. So this is basically what? Which point? Outside. What is this point? Inside. So here electric field is inversely proportional to R square. So this is the graph between electric field and position. Inside 0, on the surface KQ by capital R square. The moment it is outside, it is inversely proportional to the distance. So this small r is a variable quantity. It is changing. It will start decreasing. I hope that the reason is clear, right? So it's very simple. If you understand, then you will not mess up the things. But if you blindly mug up, you mix up the things. So you have to be a bit careful. Okay. So one question I'm asking here, make sure that you guys answer in the comment box, that if electric field is 0 everywhere inside, is it necessary that potential should be also 0 inside? Just make sure, think about this point and answer in the comment box. Let's move ahead. The next question is the most interesting question. Very nice problem. It was asked in your board exam. So बिल्कुल ध्यान से देखना next question को. So students, see this question. Very interesting problem. Mark this question as important. ठीक है? It was asked in your board exam. I think 2 or 3 times it has been asked. बहुत ही अच्छा question है, बहुत ही conceptual question है. So they are asking that we have an infinitely long positively charged wire, charge density lambda, lambda coulomb per meter. An electron is moving around it. If this is the conductor, positively charged conductor, an electron is moving around it. So if the electron is moving in the circular orbit, we know that which force is required for circular motion? Centripetal force, right? So centripetal force will be provided by what? If it is moving in the circular path, the centripetal force will be required by the force between this conductor and the electron, which is F equals to Q into E. So F equal to QE will provide the required centripetal force. So see, we are writing the equation. So Q into E, this is the force which is providing the required centripetal force, mv square by r. Now, what is the electric field due to a straight infinitely long conductor? Just now we discussed lambda by 2 pi epsilon naught r. The charge is electron, so E into lambda by 2 pi epsilon naught into r, mv square by r. So r gets cancelled. R gets cancelled. So we get mv square equal to E lambda by 2 pi epsilon naught. We need kinetic energy. So in kinetic energy, formula is half mv square. So we already have mv square. So what will be the kinetic energy? We already have mv square. So kinetic energy will be equal to half mv square. Substitute the value of mv square. So half into E lambda divided by 2 pi epsilon naught. So what is the expression? E into lambda by 4 pi epsilon naught. So this is the first part of the question. That what is the relation between kinetic energy and lambda? So we found that. I hope that कोई problem नहीं है इसमें. We just equated the forces. Electric force is providing the required centripetal force to the electron. Now second part they are asking was draw the graph between kinetic energy and lambda. So what will be the graph between kinetic energy and lambda? They are directly proportional. You can see that. Directly proportional. So whenever two quantities are directly proportional, what is a graph, students? A straight line. So the graph will be a straight line. I hope that this question is clear. A very good question, right? Not straightforward. They have basically made sure that you use the concept where forces are equated, and when they are directly proportional, graph is a straight line. So let's move to the last question. To see this question, what they're telling that was plot a graph between force and 1 by r square, where the charges are, first case, both the charges are positive. Second case, both the charges are negative. Just understand that what is the formula for force between two charges according to Coulomb's law? K Q1 Q2 divided by r square. So if you notice carefully, F is equal to K Q1 Q2 into 1 by r square. So what is the relation between force and 1 by r square? I'm not asking r square, I'm asking 1 by r square. So force and 1 by r square are directly proportional. Force and r is inversely proportional, but force and 1 by r square are directly proportional. So what will be the shape of the graph? A straight line. Straight line. If I ask force and r, then it will be a decreasing graph. But it is directly proportional to 1 by r square straight line. So let's draw the straight line. So it will be a straight line. F and 1 by r square. If you see the first case, both the charges are positive. So if I write this as y equal to mx, so this whole thing is representing the slope. K is a positive quantity. यहाँ पे दोनों charge भी positive है, right? So this whole thing will be positive. The slope will be positive. The angle formed will be acute. So this is the graph for repulsion. Why repulsion? Because both the charge are similar, right? Positive, positive. So it will be a repulsive force. Now, if you see this case, here one charge is positive, one charge is negative. So first of all, it will be attractive force. But when you substitute the value here, K, Q1, Q2, this product will be negative. Means slope will be negative. So you will draw a straight line where slope will be negative. So this thing. So this is the graph for attraction. Okay. If you want, you can extend this, but it's not required. This is fine. So this is a graph or straight line with a negative slope. Attraction, here it is positive repulsion. So I hope that funda is clear. I try to take all different type of questions depending on the graph. So you make sure that you see the lecture properly and do let me know in the comment box what is the next type of graph or next topic what you want me to discuss from the next chapter, which is electrostatic का part only, potential and capacitance. So prepare well for your board exam. I am with you. Whatever help you need from my end, do mention in the comment box. See you in the next session.